Hello students, in this our lecture of physics, we are going to learn a chapter number 9, ray optics and optical instruments. So here we are taking one example number 9 of your textbook. So figure is given and we are supposed to find the final image formed by this combination of three lenses. First one is here. First of all, we will find the image formation by lens number 1. So for lens number 1, the object distance is 30 cm and focal length is given 10 cm. Because here object is at the left side of the lens, so we will take the object distance negative. So u will be minus 30 cm. It is here. According to lens formula 1 upon v minus 1 upon u equal to 1 upon f, we have the value of u is equal to minus 30. F is our focal length, which is 10 cm given in the figure. So minus and minus will be plus, but if it will go to the right side, then that will be minus again. So 1 upon 10 and this will be at the right side, so that will be negative minus 1 upon 30, and the answer we will get, that is 15 centimeter. So this 15 centimeter, because our answer is positive, so the image will be formed at the right side of the lens. So at the right side of the lens, 15 centimeter distance will be here. So we will have to take the object distance for lens 2. If our image is here because of lens number 1, then that will be, we have as an object for lens number 2. So from lens number 2, the distance of this object, that is 10 centimeter. So we have taken here, because this is right side, so we have taken this positive. U is the object distance for lens number 2 and that is positive. And the focal length is given minus 10 centimeter. Minus 10 will be plus. So minus 1 upon 10 plus 1 upon 10, both will be cancelled. And we get the answer 1 upon v, that is equal to 0, and v2, which is our image distance for lens number 2. So that will be v2 is equal to infinite centimeter. Now for lens number 3, the object distance will be infinite. So if the object is at infinite distance, then the image will be formed at the distance equal to focal length. And the focal length of lens number 3, that is 30 cm, and image distance will be also 30 cm for lens number 3. So this is the final image formed at the 30 cm from the lens number 3 at the right side of the lens. Now going forward, refraction through a prism. We are having one prism. PQ is our incident ray, QR is our refracted ray, and RS is our emergent ray. We have found here incident angle I. This is our normal. This is our second normal of side AC. The name of prism is ABC. So here incident angle is I and emergent angle is E. Here is our first refracted angle R1 and this is our second refracted angle R2. We are having quadrilateral MQ and R. This is quadrilateral MQ and R. But as the two normals are here, so we have the angle 90 degree and 90 degree, that is equal to 180 degree. But the summation of all the angles of quadrilateral is 360 degree. So 360 minus 90 minus 90, that is remaining is 180. So we are having the summation of angle M and angle N, that is here angle A and N. This is our quadrilateral A, Q and R. So the summation of A and N, that will be 180. So we have written here that here, so A plus Q and R, that is equal to 180 degree. And once again in the triangle Q and R, this is our triangle Q and R. So R1 plus R2 plus, this is the third angle of the triangle, and the summation of all angles of the triangles is 180 degree. So R1 plus R2 plus Q and R, that is equal to 180 degree. So we have written here R1 plus R2 equal to A. So here R1 plus R2 plus Qn that is equal to 180 degree. If we compare this equation number 1 and 2, then we get the R1 plus R2 that is equal to A. So this is our equation number 3. Now we will go forward that the total value of the delta. So the delta will be, delta is here. This is the value of delta. It is exterior angle of triangle MQR. So the exterior angle, value of the exterior angle that is equal to summation of the interior angle. So this is the first interior angle which is equal to I minus R1. It is there. And here is E minus R2 that is here. So we have summation the I minus R1 plus E minus R2. And we get the answer I minus R1 plus E minus R2. Minus will be common from R1 and R2. And we get the value of R1 plus R2 from equation number 3, and that is A. So we got delta equal to I plus E minus A. That is the total deviation of our ray. Now for minimum deviation, if we want the minimum deviation over here, then delta that will be equal to dm. M is for minimum, and here I equal to E. When the deviation will be minimum, then the incident angle that will be equal to emergent angle. So from equation number 3, we have R1 plus R2 that is equal to R. So R1 equal to R and R2 equal to R. So R plus R that will be 2R, and we have the value R equal to A by 2. Now from equation number 4, I equal to E. So I plus I that is equal to 2I minus A. A will be here. So we got here that dm equal to 2I minus A, and if we make the subject I, then we get the I equal to A plus dm by 2. So from Snell's law, we have the Snell's law n1 sin theta 1 equal to n2 sin theta 2. So we have here sin theta 1 is incident angle and sin theta 2 that is our emergent angle. So we get n21 is equal to n2 upon n1 equal to sin incident angle is A plus dm by 2 and emergent angle is A by 2. So we got here for some smaller angle, sin will be removed. So n21 equal to A plus dm upon 2 equal to A by 2. So 2 and 2 will be cancelled, and we got the answer dm equal to n21 minus 1 bracket close and into A, or we can say dm equal to A into bracket n21 minus 1. So this is the value we can find for minimum deviation, and this is the value of our total deviation which we can derive the formula from this figure, and this is our sum. In next discussion will be done in our next lecture. Thank you. Have a nice day.